Hello everyone, welcome to Chemazon-Complete Chemistry. So in our today's video, we are going to learn and understand some very important stereochemical terms, or we can say some important terminologies that are used in stereochemistry or in reactions. First is stereoselective, stereospecific. What is enantioselective, enantiospecific, diastereoselective and diastereospecific. So let us try to break the words and try to understand the meaning of each term. What is the meaning of stereo? Stereo here refers to stereoisomers. Stereoisomers. Now we know stereoisomers can be of two types. One is either they are geometrical isomers. What is the meaning of geometrical isomer? Cis-trans or Ez isomers. Example is alkenes or cycloalkanes. In cycloalkanes also we can see cis-trans. And another example of stereoisomer is optical. Optical isomers, we know they are RS isomers. Molecule having R and molecule having S configuration. These are what? These are enantiomers. So in each term, if the product is enantiomers, if the products are enantiomers or one of the enantiomer, we will use the term enantio. And if the product is one diastereomer, that is cis-trans or Ez nomenclature, molecule having Ez nomenclature, then if it is one of the diastereomer, then we will use the term prefix as diastereo. Okay, this was the meaning of stereo. Now let us see what is selective. Selective means selectively one isomer is formed more. Selectively one isomer is formed in more amount, or we can say one isomer is the major and another isomer is the minor product. So always remember, whenever one product is major, one isomer is a major product and another isomer that is formed, that is a minor product or formed in smaller amount, then we call that reaction as selective. Selective means one isomer is formed major, let's say 60% is formed R. R enantiomer formed is 60% and the remaining is 40% is S. But the important thing to be noted is both the isomers are formed. That is very important. Both the isomers are formed. R will also be formed and S will also be formed. Similarly, E will also be formed and Z will also be formed in case of diastereomers, but the amounts are different. One is major and another is minor. Okay, now let us understand the meaning of specific. Specific means only one isomer is formed. Only one isomer is formed. Specific means only one isomer is formed. Either R or S, or if we talk about diastereomers, then either E is formed or Z is formed. Only one isomer is formed at one time in a reaction, then that is called as specific. Now let us understand each term one by one. First is stereoselective. So what is a stereoselective reaction? Stereoselective reaction is a reaction where more than one stereoisomer, a stereoselective reaction forms more of one stereoisomer than of another. We had seen just now, for example, 60% R and remaining 40% is S, or let's say 20% is E isomer and remaining 80% is Z isomer that is formed. Here you can see A is what? A is the reactant. and it is forming two products B and C. B is formed more, so B is the major product and C is what? C is the minor product. Now this stereoselective can be of two types. One is if there are two conditions, if B and C are what? They are enantiomers. Okay, we had seen just now, then stereo term we will replace by enantio. Okay, if B and C are enantiomers, then we say it is, the reaction is enantioselective. And if B and C are what? They are diastereomers. If B and C are diastereomers, then we say that the reaction is diastereoselective. Okay, so but the condition, important condition here is that both the isomers are formed. Okay, this is the trick to identify whether it is a selective or specific reaction. In selective, both the isomers are formed. In specific, only one isomer is formed at a time in a particular reaction. Both the isomers are formed. Okay, let us understand with the other term, stereospecific. Now, what is the meaning of stereospecific? In a stereospecific reaction, each stereoisomer forms a different product or a different set of stereoisomeric products. Now, what is the meaning of this? That only one isomer is formed at a time in a reaction, and that whatever stereoisomer we are using, that also gives a different product when they are reacted in a particular reaction. Another thing to be noted is that a stereospecific reaction is stereoselective. What is the meaning of that? Stereospecific means only one isomer is formed, which means we are selectively forming only one isomer, either R or S. So stereospecific reaction can also be called a stereoselective. But stereoselective reaction is not necessarily stereospecific. That means mostly it is seen that in stereoselective reactions, both the isomers are formed. Okay, that is why we don't call that as specific. Now, what is the meaning of stereospecific? Suppose there is a reactant A. This reaction will form one isomer B. Okay, this particular reaction, let's say reaction 1, it will give only this B isomer and not any other product. Similarly, let's say there is another reactant C that will give a different stereoisomer, that is D. So that is the meaning of this definition, that each stereoisomer, that is A and C, they form a different stereoisomeric product. B and D formed are also different. Now stereospecific reaction can also be of two types. One is if the product is a enantiomer. Okay, either it is R or S, molecule having R or S configuration, then we call it as enantiospecific. Enantiospecific. And if the product formed is a diastereomer, if it is a diastereomer, then we call it as diastereospecific. Okay, so now let us understand one by one each term. Enantioselective, if a reaction produces preferentially one enantiomer over its mirror image. What are enantiomers? They are non-superimposable mirror images of each other. Preferentially produces one enantiomer. That is what is the meaning of major product. Why we call a product as major product? Because it is formed in larger amounts. Then that reaction is called as enantioselective reaction. That we had seen just now. If in any reaction there is major and minor products, both major and minor products are formed, then that reaction is called as, and both these isomers are what they are? Enantiomers. both the major and minor product formed are enantiomers, then we can call that reaction as enantioselective. Let us understand with the example. Here you can see that there are two cases. One is ketone. This is reactant is what? This is R C double bond O R dash. This is a ketone. And here what we are doing? We are reacting it with lithium aluminium hydride. LiAlH4 is lithium aluminium hydride, or it is sometimes also written as LAH. This is what? This is a reducing agent. And here it reduces by donating what? By donating H minus ion, or we can also call it as hydride donor. Okay, so we know that this carbon, it is sp2 hybridized. That means it is planar. Now H minus, there are two possibilities. It can attack either from above the plane or from below the plane. If it attack from above the plane, then we will get R enantiomer, and if H minus attack from below the plane, then it form S isomer. So if RS possibility is 50-50, that is 50 is to 50, 50% probability, or we can say 1:1 ratio of the product is formed, then we can say that it is a non-selective reaction. Non-selective means R can also be formed in equal amount and S is also formed in equal amount. Both the enantiomers are formed in equal amount, then we don't call it as selective. Okay, then it is not called as selective. It is called non-selective reaction. Any isomer can be formed. But if I introduce L star, what is an L star? L star is any chiral ligand. Okay, so what happens? One enantiomer is formed in excess. R is what? R is the major product, and S is formed in 16%, that is S is the minor product. So here you can see both R and S are what? They are enantiomers. So I write the prefix as enantio, and both the isomers are formed. Both the isomers are formed, so we call it as selective. So this is an example of what? It is an example of an enantioselective reaction. One of the isomer is formed in as a major product, and other isomer is also formed but in lesser amount. Now let us see what is a diastereoselective reaction. If a reaction leads preferentially to one diastereomer, okay, one diastereomer, let's say E isomer is formed as 80%, that is the major product, and Z isomer is formed, that is the remaining 20%. Then, okay, but both are formed and both are E and Z are what? We know they are diastereomers. So, if a reaction leads preferentially to one diastereomer over the other, then the reaction is called as diastereo because diastereomers are formed, and selective because one of the diastereomer is major and another is a minor product. Let us understand with the help of an example. Diastereoselective reduction of cyclic ketone. Again, it is an example of reduction of ketones. Ketones are reduced to what? They are reduced to secondary alcohols. Now here there are two cases. One is they have used lithium aluminium hydride, that is a small hydride donor, or we can say less bulky reagent. Okay, and another case is dibal H. Okay, this is dibal H diisobutyl. This is what group? This group is called as isobutyl. Why isobutyl? Iso because two methyl groups are attached to the same carbon, which are same. Iso meaning same. And this is 1, 2, 3, 4. Total 4 carbons. So that is why it is called as isobutyl. Di because two isobutyl groups are present. So diisobutyl aluminium hydride. Both these are also what? They are hydride donors. So now the question is, here if you see, this is a chiral carbon, and if we see methyl has 3 CH bonds. So it is a bulky group. Okay, and a hydrogen is a small group. And so what will happen? Hydride would prefer to attack the carbonyl, this sp2 hybridized carbonyl carbon, from where? From below the plane. From below the plane. Why? Because here already there is a methyl group which is bulkier. So if hydrogen attacks from the top, it would create steric hindrance, and that is why this product, if you see, it is major product. It is formed in 76%. Now, since the lithium aluminum hydride is a smaller molecule, you can see this is the structure of LiAlH4. As compared to dival H, lithium aluminum hydride is a smaller reagent. So what will happen? H minus can also attack from top, but it is very less. So this is the minor product. Okay, but what will happen when we use dival H or diisobutyl aluminum hydride? It is a bulky hydride donor. So only one product is formed. 100%. This one product is formed because since this is a bulky reagent, it cannot attack from the top because of the already present bulky methyl group. This will cause a lot of steric hindrance. Okay, so if you see the first reaction here, both the isomers are formed, but both the isomers are formed, they are diastereomers. So I would write diastereo, and since both the diastereomers are formed, one is major, another is minor, I would write the term selective. Okay, one isomer is selectively formed as a major product. So this reaction is an example of diastereoselective. If I talk about dival H, only one diastereomer is formed. Then that second reaction is what? This is an example of diastereospecific because only one isomer is formed. And it is what? It is a diastereomer. And how do you come to know it is a diastereomer? We have already seen. At the second carbon, the configuration is same, but at first carbon, the configuration is changed. We know that if out of the total stereoisomers possible, stereogenic centers, if at any one or two position, configuration is changed and remaining configuration is same, then we call them as diastereomers. So what we have to do, first you have to find out the products, they are diastereomer or enantiomer. If it is enantiomer, you write enantio, diastereomers, then you write diastereo. Okay, now let us see what is enantiospecific. Enantio means enantiomer is formed, and specific means only one enantiomer is formed. Only one enantiomer is formed. The best example of enantiospecific reaction is it is a SN2 reaction. What is an SN2 reaction? It is a single step, or it is also called as concerted reaction. Concerted means single step reaction involving a transition state. And here what is the stereochemistry? There is always inversion of configuration. What is the meaning of inversion of configuration? The configuration is changed. If the reactant alkyl halide has R isomer, then the product formed is S enantiomer. That is, the configuration is inverted or changed. If we use a S enantiomer, then the product formed is a R enantiomer. So this is an example of what? This is an example of enantiospecific reaction. Why? Because R is what? R and S are what? Enantiomers. And in one reaction, this first reaction, only S isomer is formed. And in second reaction, only R isomer is formed. Specifically, only R is formed. So that is why we call it as specific. Enantio means enantiomer, specific means only one product is formed. Similarly, diastereospecific example is E2 reaction. Sorry, E2 reaction. Why this is called diastereospecific? Because here always anti-periplanar transition state is required. That is, hydrogen and the leaving group, they should be anti means at an angle of 180 degree. Periplanar means in the same plane. And in this reactions also you can see only one isomer is formed, either Z or E. That is why it is called as diastereospecific. So here we come to the end of today's video. Thank you.